together and talk about this. Who can come up and just complete this table as you have it in your journal? Oh, thanks. So we can just kind of compare this. And as he does, I want you guys to just make some observations. What did you notice about the area? What was that?
The area was cut in half as well. Not just the bandage wood, not just the bandage wood, but the area was too.
Okay, so the area of was cut in half. Okay. Does this pattern look familiar to you at all?
Yes.
Who said yes? This pattern looks familiar?
Yeah, it's the one from the board.
It's the one from the board?
Well, it's similar.
How is it similar?
Because when I was working with my partner, I saw that 32 was there. So then I told her that what if instead of multiplying by 2, dividing by 2, and that's how we got our answers.
Interesting. So instead of multiplying by 2, you looked at this as dividing by 2. So you're noticing that whereas in the Ruba's problem we were doubling, what was happening here? What was happening here then?
It was like decreasing, but like doubling as it decreased.
Doubling as it decreased. What does that mean?
That
Explain that.
like the numbers were decreasing, but they were getting divided by 2.
Okay, so they're being divided by 2. So instead of multiplying by 2, we're dividing by 2. Ellen, thank you so much. So we could say that initially if we had 64 squares, what happened to that 64 that then it became 32, an area of 32? How else could we say that it was divided by 2? Yeah. Okay, so we multiplied it by half. What then would have happened in this calculation to find the area of 16? So if we had multiplied it by half,
It would have been 32.
okay. So then, Giselle?
So you multiply 64 times half to the power of
To the power of?
n.
Okay, but what about specifically for this situation though?
Then you multiply by another half.
Oh, okay, so we're multiplying by another half. And then the calculation that would have taken place for the third cut? Okay.
What do you just keep on doing the same? You just add another.
Well then, you just keep on adding another half every time? Well, what if I want to jump ahead to this one? How many times am I going to be multiplying half?
6.
How do you know this without having that previous one?
Good.
Because the number of cuts.
As Beto said, it's one more every time, but how do you know this?
Because it's the number of cuts that you're cutting.
So it's the number of, so you're relating the number of cuts to how many times we're cutting this in half. So if the number of cuts was 6, then you're saying that the half needs to be there 6 times based on the number of cuts. Did we figure out an equation for this?
Yes.
Because Giselle had mentioned for any number of cuts, n number of cuts, what could the possible equation be? Stephanie, come on up.
I think 64 because it was that area for
interesting. So you're calling this 1/2 our growth factor. What do you guys think about that? What do you think about that? I mean, I'm looking at the way Stephanie set this up, and Stephanie mentioned the 64 is our y-intercept, which is also our. Okay, and then she was mentioning that this was our growth factor. Tell me your thoughts on that, growth factor. What do you guys think?
I disagree.
How about this? How about this? Can you take about 60 seconds with your group, and let's take exactly where Stephanie left off. She said 1/2 is our growth factor. 60 seconds, what do you think? What does that mean?
It's not a growth factor because it's not growing. If it was a growth factor,
kind of divided it already. Here we divided it.
the value would have been 64 and it would have been growing.
So what would you call it then?
Growth decay. Because instead of growing, it's decaying.
Jessica, Ellie, and are you convinced?
Instead of growth factor, we would call it a decay factor.
Growth decay.
It's not growing at all. It's actually.
Well, it's like kind of.
All right, so students, 60 seconds is up. Let's talk about this. Jose, tell me your thoughts.
I would not call it a growth factor because it's not growing. It's actually decreasing or like getting smaller. So I would call it a decay factor.
What do you guys think about that? Possibly a decay factor? It's not growing, it's getting smaller. Speaking of getting smaller, can this pattern continue?
Yes.
Because I had this nice little discussion with Ashley's group over there. Tell me about this. Evelyn, what do you think about this pattern? Can it continue?
I think it, just because we keep dividing it by, well, we're dividing it by 2. So, if we keep on dividing the number that was next from this, so we can keep on going.
So there was always some number that you can divide by 2, and you always had some result. Someone had originally thought that eventually this will turn negative. What are your thoughts on that? This pattern gets so small that all of a sudden now we're talking about negative numbers? Andy, what are your thoughts?
It can turn negative because if we have 0 cuts, we have nothing, and we can't cut nothing because there's nothing to cut. There's
Nothing to cut. But would it result in a negative area? Tell me about a negative area. Yes.
I don't think it could be a negative area because when you're using an exponent, the answer for the exponent can't be negative, it always has to be positive.
Okay. Jose, ask that.
I don't think it can turn negative because if you keep cutting it, like you're still cutting some paper and you're not saying like I'm cutting, like the number of cuts turn negative.
Okay.
So, like, it's always going to be positive. It's like because there's still always going to be paper to cut.
There's always going to be paper to cut. Sure. Go ahead.
I would say it can be a negative because even though like the more you're cutting a square, and the more smaller it gets, the only thing that's changing is the denominator because it gets smaller. Like from right there, like this is 1/2, and then it changes to a 4 and 16. Like as you cut it more, it's gonna end up changing to like a 32 and then.
Okay, so you're noticing that the denominator keeps on changing, resulting in these smaller and smaller.
Stays the same.
Sure. Jose.
And also, I don't think it's possible to keep cutting so much that it turns into nothing.
It's true, right? So I mean, technically, I mean, if you were actually cutting this, and you get to the point where maybe you couldn't physically do it, But if we're looking at the numbers, there's always something that keeps on getting cut in half. Giselle, last comment.
Because negative is when you owe something and you're cutting paper, so you're not like taking it away, you're just making it smaller.
Absolutely, absolutely. Wonderful. Last thing I want to ask you, how is this different from exponential growth? And how is this similar to exponential growth? Did you guys figure out those similarities and differences? So now we're looking at exponential decay. Relate that to exponential growth. Its similarities, its differences. How many of you have had a chance to discuss with your groups about this? Its similarities and differences. Okay, can we take another 60 seconds to 90 seconds to discuss with our groups similarities and differences? And then we're ready to share out? Okay, I'm sorry.
Differences with that.
One is decreasing, the other is increasing.
Yeah, like the growth rate, the growth factor.
One has a growth factor.
The ones that we used to do have a growth factor, and these have a decay factor.
Which means one is increasing, the other is
Yeah, or they have a factor that is less than a whole, and those ones have more than a whole. So, yes, yeah, look at this. You can
Yeah.
the graphs go from left to right, and then this one decrease down to left.
Yeah.
All right, students, time is up. So let's share out similarities, differences. Tell me your thoughts. Same hands, come on guys. Jamie, tell me.
I think that the difference about it is that exponential growth goes increases and this one decreases.
Mm-hmm. There's a difference. Adrian.
There's actually no, well, but I think that there's actually no difference because in the area, they still go, at first it goes, it's increasing, and then it goes decreasing, which is the same thing in the graph.
So you're seeing that the graphs were similar in their shape?
Kind of.
They kind of were? Carla, answer that.
The similarity is that in the table, it will always go up by either a growth factor or a decay factor.
Okay. So there's either a growth factor or a decaying factor. Interesting. You know what I think is great? I think it's great that Elsa's sitting here with her pencil, and if she's hearing things that she doesn't have in her journal, she's taking a opportunity to jot this down, because some of us have other ideas that we didn't think of. So this is an awesome time to kind of share and get that information into your journal. Yeah.
What Carla was saying about the similarities, what she meant was that both patterns were exponential.
As opposed to what?
To like linear, where they have straight lines.
Amazing. Okay, so what you're noticing is that yet again, in this pattern, it's still exponential. We're not moving at a constant rate like we do when this is a linear pattern. What a great observation to make. By the way, that's resulting in how's this graph appearing then? Because we're talking about something being exponential. Jose?
Instead of the graph, like in other lessons, instead of it growing from left to right, it's decreasing from left to right.
Okay.
So like instead of looking like this, it's like backwards.
It's like backwards, right?
What
Okay.
else did you mention during your discussion
That
about fractions?
in the growth decay or the growth factor, it's less than a whole, so then that means it's probably decreasing. So
You know what's interesting is, who was it the other day Annie, didn't you mention something? Remember you asked a question the other day about a growth factor? Do you guys remember his question from the other day?
Yeah.
What did he say?
he said, what if the growth factor is less than a whole?
Do you guys remember this just the other day? We were talking about like a growth factor being more than 1, and we were looking at growth factors that are not whole numbers. We were looking at like 1.4, we looked at 1.8, 1.6, and then Andy said, well, what if it's not even 1? Here you go. What happens if it's less than 1? What did you find out today? What happens if it's less than 1, Andy? Answer your own question. Okay, so we see this decreasing pattern. There you go. All right, I need to see sheet of loose leaf paper, proper heading. I have an exit slip for you.